In this video, we'll look at factorial notation as well as permutation and combination. A factorial is a way of counting the total possible outcomes of independent events. So a factorial is multiplication of an integer from n to 1. And a probability, we call this counting without replacement. And the without replacement means that imagine that there's a bag of marbles, and I want to know what is the total number of ways that I could pull a marble from the bag, or total number of orders that I could pull a marble from a bag. Well, once I pulled the first marble out, I wouldn't count that as the number, another or a second possible outcome, because it's pulled out of the bag without replacement. So imagine putting 12 marbles and 12 or red marbles and 12 black marbles in a bag. The probability of choosing a red marble from the bag below is 50%. But what if the marble isn't replaced? Well, now that probability changes. The odds change. In Vegas, it's called card counting, and it's actually illegal. Maybe you've seen the movie a few years ago, 21. And the idea is that as you see the numbers that are revealed out of a deck, it removes that possible outcome from the deck such that the probability of seeing another card, a higher card or a lower card, changes as you continue to play. Factorial, as you've learned in your math class, is just a series multiplication. So we take the n, or the number of items or events, and we multiply sequentially from n to n minus 1, n minus 2, so on and so forth, all the way down to 1. So if we visualize a factorial, imagine that there are 3 candidates for a position, or in this case I've said there's 3 people that are walking into a bar, and we want to know the number of different ways that they could, or the orders that they could walk into a bar. So sometimes factorial, or the term factorial, is commonly referred to as ordering. You're counting up the number of orders. So we have these 3 different people, and you can see visually that there are 1, 2, 3, 4, 5, 6 unique ways that these individuals could walk into a room. And with 3, it's pretty easy because you can see, or you can imagine how those 3 work. But imagine if you go to 4 or 5 or 6, or for example, if I wanted to count the number of ways that 30 students came into my classroom, there are trillions of different ways. And the way that we calculate that is we take the number of individuals, or the number of events, and we take the factorial of it. So in this case, it would be 1 times 2 times 3, or you can reverse it, 3 times 2 times 1, and in that case it's 6. So for example, if 24 students were in this class, and I wanted to know, okay, how many different ways can those 24 students walk through the door and come into the class, or maybe even leave? The number of ways is 6.2 times 10 to the 23. I don't even know how large that number is. In Excel, we use the function factorial. And they've shortened it so it's just fact. So I put in 24, and all it has is just one argument. And I can count that, and you can see that it's a very large number. How large is e to the 23? Let's see if I can just stretch that out for you, and you can see how many zeros that is. It's an incredibly large number. So 20, there's trillions or zillions. I'm not even exactly sure what that would be, what the name would that be, but there's so many different ways. So imagine a basketball team. There are 5 individuals on a basketball team, and I'm going to order them from in some way. How many different ways can I order a 5-member basketball team? And the number is quite surprising. Even with a very small number, there are 120 different ways that I could order 5 individuals. So let's try a few. How many ways can I order my box of crayons? So in this case, we could use the fact equation and put in 8, or we could calculate it, and it would be, 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. I certainly prefer the Excel method. It just is quite easy to do. So I put in there fact 8, and there's 40,320 ways. Well, is that correct? 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. We get the exact same number. So that's the ordering, or factorial. How many ways can I order a beauty pageant? I'll leave that one to you. You can just type in facts 12, and it's surprising how many different ways that you can do that. And then order the number of class, and you saw that that was an incredibly high number. All right. Let's take a look at this and combine the factorial with the mutually exclusive and independent events. So let's assume that I can only afford one item on the menu. How many items are available for lunch? So in this problem, all items are mutually exclusive because I can only afford one. So we use the addition principle of counting. We can see that no items are duplicated. Therefore, the total sample space, or number of possible events, the number of items that I can choose from, is 12. There are 4 sandwiches, 4 salads, and 4 soups, and we add that to get 12. The deli's offering a special. I can choose a 3-course lunch offering of my choice 1 sandwich, 1 salad, and 1 soup. In this case, if I order a sandwich, it is mutually exclusive from another sandwich, but it is independent from my choice of a soup or a salad. So we would use the multiplication rule to calculate the number of different possible combinations. So let me go back here. I've got 4 sandwiches, 4 salads, and 4 soups. So I could do a ham, a house, and a broccoli. I could do a ham, a house, and a tomato, a ham, a house, and a taco, and so on and so forth for every single one of those combinations. And so you can see, just with 4 items, I really can't do it by visualizing those. But if I just recognize that there are 4 mutually exclusive events, but each one of those 3 categories are independent, I'd use the multiplication rule between independent events, and I could see that there are 64 possible combinations. And finally, I order all 4 sandwiches, 1 each for me and my 3 friends. I put them into a bag, and I want to count the total number of ways that I could draw those 4 sandwiches from a bag. So if my friends are lined up, and you could think that there's only one possible way that they could all get the right sandwich, The denominator is the number of ways that I can pull the sandwiches out of the bag. The denominator is the order, or the ordering. There are 4 possible events, so I take the factorial of 4 times 3 times 2 times 1, and I see that there are 24 possible ways. Now let's go back to the classical approach. So remember, the probability is the number of things I'm looking for, which is getting the right sandwich to my right friend. There is only one way that that can happen. If you switch any of those sandwiches, then somebody did not get the right sandwich. But when I pull them out of a bag without looking, there are 24 different ways. There are 24 different ways that I can pull that sandwich out of a bag. So the probability that my friends will get the right sandwich just purely by random chance is only 1 out of 24.